Hey, what's up, guys? My name is Cherno. Welcome to the very first episode of the Cherno Podcast. Something I've never done before, something I'm very scared about. I have no production team behind me. I'm going to be doing all of the stuff here, so if the audio levels are rubbish, you guys have to let me know. But I'm very excited to start this new podcast thing. It's something I've wanted to do for a really long time, and I think it'll be cool to kind of talk to you guys in a live format as well about various topics relating to like programming, game engine development, whatever it is that's going on. And hopefully we can have some really interesting guests on this show as well, because I do plan to hopefully try and include guests in pretty much every single episode. So this episode is actually sponsored by PVS Studio. So for those of you who have heard of PVS Studio, will know that it's quite a nice piece of software to have with you as you're developing your own software. PVS Studio is a static analyzer, and what a static analyzer is basically like a little friend to help you when you're programming. So it's kind of like a spell check for like your Word document or whatever, but it's for your like C++ code or Java. They support a few languages. There you can check out PVS Studio by going to the link, which is here. And if you're watching this on YouTube, there'll be a bunch of other links in the description. They also have a Facebook page and stuff like that. But I recommend you guys hop on that. If you use the code #Cherno in the message field, you'll also be able to get yourself a free trial and try out the static analyzer for yourself. And that's actually a pretty decent segue, I think, into the guest that we have today, because our guest is none other than Yuri from PVS Studio. So why don't you say hello?
Yeah, what was I saying? Oh, yes, right. Thank you for bringing me here. Because I'm watching you on YouTube I've been watching you for like a year, probably, maybe more. Not regularly, because, who watches YouTube these days regularly? But I stumbled upon your channel when I was trying to figure out how to make a game engine. It was a passion of mine, and it still kind of is. It's just on pause right now because I've got a ton of development and related things at work, and sometimes when I go home, I just want to, take a break from it.
Okay, so that's pretty cool. I didn't know you were into game engines, actually. That didn't come up in any of our previous conversations. It's very relevant.
It was my dream to become a game developer a while ago.
Cool. A while ago. So that's faded?
No, it's on hold, on pause.
Okay.
Now, I still, of course, I would like to get into the game industry one day, but where I live, it's difficult to do. And I would either have to move or do a remote job to do some of the cool stuff,
Mm-hmm.
So I'm still thinking about it, but right now I've got this thing going with the static analyzer, which is basically a compiler out under the hood. It's not the entire compiler, but it's still interesting. It's the front end part which actually deals with the language itself, and it processes type information, syntax, and stuff like that.
Yeah, I think it's probably worth talking a little bit about, because I think maybe you said that in the first kind of section, but we missed that now. So you work at PVS Studio as a software engineer, and you're working mostly on you were saying the front end compiler stuff. Maybe just talk a little bit about what it is that you do at PVS Studio.
I'm doing the core module for the C++ analyzer. And, we have several of them. We have C++, we have C#, and we have Java. And I'm in the biggest one, which is C++.
Mm-hmm.
So what I usually do, I fix bugs mostly, because it's a big old project, obviously.
Yeah.
And recently we've started doing some refactorings, changing big parts of our tool, and I was a part of it. I actually implemented a new type system for the analyzer, because we need to understand types of variables and whatnot.
Mm-hmm.
Well, also I'm doing diagnostic rules, which is an interesting thing by itself, especially when you have to go fix something in the core because you come across some either missing functionality or a bug when you are doing some diagnostic rule for the analyzer.
Right. Cool. So that's pretty interesting. C++, C#, and Java. So, okay,
Java.
So here's a question for you. Since you were saying that the code base is pretty old, how often do you guys run PVS Studio on the PVS Studio code base?
Oh, that's a platinum question. Come on, everyone asks it. Yeah, every night in our CI, it runs on the entire code system, and before we commit any changes to the repository, we also test locally. We run PVS Studio on PVS Studio and see if it finds anything funny. Yeah, and if you don't do it during the day after you made some changes, you come to the office in the morning and you get a nice little message which says you screwed up. Here's what you did. You should be ashamed of yourself. So it's an automated spam email which sends you all the new warnings the analyzer was able to find on your code that you wrote. So it's kind of embarrassing.
Yeah, no, it sounds similar to like continuous integration that we had back when I worked at EA, which was just like, any time the build was broken, it would email everyone, the whole team, and it would be like, this is the person who broke the build, this is their commit, and it would even print like all the errors from the compiler. And then usually we had something that would basically, we had TVs like hanging around like our kind of development area. And then it would just like the scrolling text, like HTML, like marquee, would just like scroll across being like Cherno and then like red and then like ships sinking and all that stuff. So yeah, good times. It's always good to blame people.
Oh my goodness. Our guys from the management will probably be watching this. So better not give them funny ideas.
They might take some of those ideas. No, well, actually, it's funny because it is a bit of a joke. But to be honest, I feel like after that happened to me a few times, I definitely like paid more attention to my commits because I had this thing where I would just forget to commit a file, and I mean I still do this with Hazel and people yell at me, but I would just just forget to commit a file, and obviously that would break the build and everything. So I remember I would always double check all of my builds after that, all of my commits.
Yeah, I think you learn that fast especially when something bad happens. Like a crashed build and smoke everywhere, and usually we have our team lead shouting. So if you go enter the office and hear build is broken again, what the you know what happened usually.
Yeah, so I think that like since we have you here today, I think it would be because I did mention this is supposed to be like a bit of a programming kind of development podcast, and I mean it's we'll see where this goes, but ultimately like I thought a good topic for today's podcast would be how to write good C++ code. So in other words, in all of your experience, and I'm very interested to hear about your opinion on this, because I deal with a lot of C++ code. I deal with a lot of questions from people being like, how do I learn C++? How do I become better at C++? Like, what even constitutes good C++ code? How do I know that I'm writing good C++ code? And since you work at PVS Studio, and you have for a couple of years now, and you obviously deal with software that is supposed to find problems with people's code. I think there's a lot that we can kind of talk about there, and hopefully give some advice as well to all of our listeners. As to maybe how they can improve no matter what level they're at, and what kind of some of the problems you see often are. Something just fell. Anyway, continue.
All right, so I guess I'll start from far away, because just how I got into this thing, programming.
Mm-hmm.
I had
That's a good start.
Pascal.
We can start from the beginning.
Yeah, I had Pascal at school, and we had a very good teacher, so I loved it. But I didn't have a computer because I grew up in Russia in 90s, and it was, interesting times in terms of what happens in the country and in terms of what kinds of computers are available. So I didn't have it. And at some point, I learned about this funny language called C. And I thought, sounds interesting. Let me check it. So I had a book on C and C++, and I learned it using the book because I couldn't even try it at first. And then I got a computer. I began just, trying things out, testing this, trying that. And then I got my first job, not really related to programming. Then that's not an interesting part. Then I got a different job, kind of related to programming. And now I'm at PVS. What I mostly did, like with programming and with C++, I did my teeny tiny, pet projects. And that's where once I decided to, okay, I'm writing a game engine. I want to be a game engine developer. I don't really know how it works, but okay, the internet will help me. I will manage. So I made kind of a bit of monstrosity, which is under a rug now because I need to fix it big time. Yeah, and a couple of different projects. I had a game when I was going on the interview at PVS. I decided to refresh myself in terms of coding and write something big. So I wrote what was it? It was a Space Invaders clone and a cockroach simulator. A little thing was running around on the map, finding food, dying of hunger, and stuff like that.
That sounds cool.
Yeah. And that's kind of my story in short. So I've learned most things in practice. I had some programming at the university, but it didn't really help. So I guess the first thing to become a good programmer, a surprise, you have to write a lot of code.
That's what I always say.
Yeah, I think that's inevitable because you really have to go out there and write. And it's like, if you ask a writer how to be a good writer, what first advice you would have, right?
Right.
So go and write a lot. Yeah, and regarding small things, I think it's all about actually about readability. So you need to write your code in a way that reads like a sentence. You shouldn't stumble when you go through the code. You should be able to read it smoothly. If you can't read it smoothly enough, maybe you should do something with it. Well, as an example, let's say you have a condition somewhere in your function, and it says if this and that and that and also this or something, right? It's impossible to read usually because it will be your condition will be like bloated with details and uninteresting stuff. So in this case, what I'm getting to is put blocks of code which are difficult to read in functions. So decompose it, make it modular. And if you noticed, I haven't said anything about the code itself yet. just about the structure. So I think that the way you structure your code is more important than your, I don't know, knowledge of some fancy constructions or something like that. If your code is well structured, it will be good. Even if you write your algorithm in a bad way, inefficient, who cares, honestly? You can rewrite it later. But to rewrite it later, you have to read it. You have to be able to understand what's going on there. Who said that? There was an advice from someone, from some big guy, who said, write your code in a way, write your code as if the person who will read it is a paranoid maniac who knows where you live, something like that.
Yeah, I've heard that one.
Yeah, so I guess that's the first and the most important thing. And about small things, what I found beneficial really is, believe it or not, to use auto a lot. I think the only type, when I declare a variable, the only type I write explicitly is bool. I don't know why, because I don't know, 4 letters maybe, or maybe bool is so insignificant of a type. So, and there's a good reason for that, actually, because I mentioned refactoring, which we were doing, and I can tell you, I can tell a little bit about that. Yeah. So if it's fine.
Yeah, sure.
If I don't bore you with details.
Before you do that, I just wanted to mention a few things. Yeah, like I totally agree with what you were saying. I think that, yeah, there's so many things here to talk about, but you pretty much said them, so I'm not going to repeat them. But yeah, basically, first of all, again, it's almost surprising to me the amount of people who actually talk about or ask me or ask anyone really, you know, how do I improve? And the thing is, I guess I was kind of the same as well when I was younger, and I'm not sure if this is just young people. I presume it's not, but the way that you improve at really anything in life, really is by practicing and by spending time at that thing, right? I mean, for most things in life, time spent, the more time you spend on something, it's directly related to your skill level at that particular task, right? Programming is no different. And I think that it's kind of, because programming is so technical, I think that it's very easy for a lot of people to get caught up in the theory and reading like textbooks or thinking, you know, that was rubbish. I'll try and get this other book and then maybe that will help me better. But I always compare this to like learning to play a musical instrument. Like if you're trying to play guitar, and I think I read somewhere online that you do play guitar, don't you?
I kind of do. I'm not good at it. I can play like a couple of songs by Pink Floyd and without solos, before you ask.
Nice.
Yeah, and a couple more. So it's my skill there is rubbish there, basically. I'm trying to improve, but yeah, you just can't do everything in life. Well, I certainly don't know a recipe how to do everything.
Yeah, of course.
When you have 24 hours a day, so
no, it's no time. There's very little time. The older I get, the more I realize how little time there is, I think. But yeah, like to do with that, like I think that you know, if you were learning a musical instrument, like it doesn't matter how many books you read or how many videos you watch on YouTube, you're not going to be able to just, you know, after 100 hours or 1,000 hours of theory, pick up a guitar and just play. You know, because you don't have the actual like muscle skills or any kind of like any idea of really what to do unless you jump into it practically. And I think the programming is very much the same way. If you just kind of read all these books and read code even without actually writing it and trying things for yourself and failing repeatedly and, you know, not overthinking things, but, you know, what you said about performance as well is like, who cares if it doesn't perform very well? I still fall into the trap of just sitting there being like, nah, I shouldn't write it this way. Like that would be bad. But then in a month, I might be like, okay, life is too short. I'm just going to make this work. And then if it's a big problem, I'll solve it later, because my goal usually when I'm programming is to create something. It's not to just Programming itself is not a puzzle I'm trying to solve. In some cases, it might be, but usually there's a product on the other end of that code. The code is supposed to create something. And then at the end of the day, if it creates the thing that it's supposed to create, that's my goal, not to solve the problem in as fancy a way as possible. And I think that that's something that a lot of people fall into as well.
Yeah, but at least read Scott Myers. I think his books are great on modern C++ because he has pretty good information. And oh my God, what I was going to say? Oh yeah, about that writing a product and not solving a puzzle programming wise. I think you should aim for that MVP concept, a minimum viable product.
Yep.
So if you have that, if it works, that you're good, basically. You can improve it, you can build upon it, but you don't have to do it like perfectly. It should work. The first thing, it should work and it should be somewhat finished. So it should do things which are logically complete.
Yep. Yeah, I think that like the whole MVP thing is definitely something I've been doing in my Hazel engine because at the end of the day, I think that like it's interesting coming from EA working on like Frostbite and other engines to working by myself mostly with a few amazing contributors as well from the community, but still mostly by myself. Like it really puts into perspective how little resources that is to build something as complicated as a game engine. And so MVP, I feel like, is almost my middle name because at EA, I would have spent way more time on this tiny feature, like a month on like this just tiny thing. But, with my engine, it's like, no, I have to move on from this. I can't spend a month on this because that's all the work that is sometimes going to happen on the engine. It might be that. So I can't spend like a month designing a UI panel and trying to like hook it up so it's really cool. That's not going to happen. So yeah, MVP I think is really important for a lot of people probably watching this because a lot of you are probably working on small projects maybe and you're not working in a large team at an organization yet. You're still learning. So just keep that in mind. Like small steps, try and kind of finish an entire slice of a feature first, and then maybe return and fill in all the blanks and the details later if you have the time to do that.
Yes, and another advantage to doing things this way is if you have a big project ahead of you, it will be overwhelming. It's guaranteed, especially if you're alone. But if you can see progress, like, oh, cool, this little thing works. Oh, cool, I can test it and see what it does. Oh, by the way, one thing I heard, and I kind of agree, is when you are making something, the first thing you should do is to put something on screen. Like as soon as you see something on screen which your program produces, it gives you motivation. It kind of makes things not that hard in perspective. So it's a psychological thing, but for me it works.
Yeah.
If you're sitting there writing in a library or something and you don't see how it works, it becomes boring. You become afraid of not finishing it, stuff like that. So put something on screen.
Yeah, no, definitely. And that's, I think maybe like that's why I like rendering so much. And I think that graphics programming is great because at least in my mind, that's one of the, well, again, in my opinion, one of the coolest things you can do with code is actually create something visual on the screen out of nothing, basically. And like that's really good. It's even cooler if you're not using like, a graphics API for your GPU, but you're actually like rasterizing everything yourself in your own software renderer. That's where I started programming. Because that's even cooler because it's like every pixel, everything you're doing is just an array of numbers which you're manipulating, and yet they make an image. And I think that's definitely super cool.
Yeah, first time I tried to show something like I don't even remember what it was. I think it was my Space Invaders clone. I used Windows API and I just created a window myself and used the GDI to render everything and put sprites there on screen. So, and then I saw it and I was like, oh, well, it's rubbish, but it's cool. I made it. It works.
Yeah.
Great.
Yeah, no, definitely. Oh man, I remember that passion I kind of had for programming. I mean, I still kind of do, but I think that it was kind of more magical in the beginning for me because I didn't understand how anything worked, and it really was like magic. But now I'm sitting here like as an adult, being like, well, there's more to life than programming, first of all. And also, why is it so difficult to draw this triangle, or why is it so difficult to do this? And it's like, I feel like it's more like it's almost like it's turned into work now, obviously, which is what it has been for me for a long time. But back when I was in high school and I was teaching myself, programming, because I wanted to render graphics on my own without using a 3D program, like for offline rendering, that was really cool when I was kind of learning that and trying to actually put pixels on the screen and succeeding. Yeah.
When you just begin is like, pointer, what is it? My goodness, I will never learn that. And
well, actually, I started with Java, so no pointers there.
Yeah, references. Everything is a reference. Yes, and when you're doing it for like several years, it's like this new feature, what concepts? It's not that convenient as I would have liked, but okay. So as you get more experience, magic kind of goes away, it washes away from what you're doing.
Yeah.
But it's still interesting. So I guess don't discourage anyone.
No,
Let's
no.
not discourage anyone.
No, I think that it's like I still get super excited when I read like some article or some paper about some new technique for like rendering grass or something, and I'm like, oh man, I need to try that. And usually that's like sometimes why I get nothing done for a week, is because instead of fixing existing problems, I add grass to the engine. I did that a few months ago, and I was like, okay, I want to try this out. So, but without that, I think that like why not do that? Because I think that keeps the passion there, that makes it fun, and I think that you need to look for that as well whenever you're working on something.
Yeah,
otherwise it's soulless.
If you find something really interesting which turns you on, it kind of brings some of that juice back into the thing.
Yeah. Yeah, cool. So, okay, so yeah, you mentioned you started programming with Pascal. Have you had much experience with languages other than C++ in your kind of modern, we'll say, life?
Well, I had some with JavaScript. Don't hit me. And don't hit me again, but I don't understand why people hate it. Some people do. Like hate it a lot. Maybe it's associated with some scripting and not interesting stuff or something like that. But it's kind of a pretty cool language to use, especially if you know C or C++, it will be easy to understand.
Yeah.
I did some Python, but not much. I was just playing with Python basically. What else? Well, basic, obviously. I remember I used to write macros for Word. I think it was for Microsoft Word in VBA and using its API. I don't know why I did it. I needed something from Word. I wanted to do something which it couldn't do, and so I did that. And one of my jobs previously, which I had, it was related to applications for testing, and they had JavaScript and Visual Basic and later Python under the hood, and you could use them to write testing code for UI. So that's where I also tried some of that stuff.
Interesting.
Well, I also did a little bit of C#, just a little bit.
Yep.
I don't really like it.
Yeah, I really like C#. C#'s probably my favorite language after C++.
I don't
Why don't you like it?
It's well, let's take JavaScript, right? It's like C++, but it's different. And C# to me, I guess it looks like C++, very close to C++, but something is missing, something is off. Well,
Right.
maybe I just don't have much experience with it. Maybe that's why I have this opinion, but I'm not really a fan.
Yeah, I think in university, yeah, actually, that's one thing I really wanted to say as well, is that because you were talking about how university didn't really teach you much, and then practically is where you learnt a lot. I'm the exact same. I say this all the time. And again, like I still haven't really met anyone who was like, oh man, I'm so happy with my university programming education. Like they taught me all the languages, they taught me all the stuff. And I know that universities like that exist, because every now and then I'll run across like some GitHub repository that is like some course on graphics, and they're actually like generating like grass in Vulkan using a tessellation shader, and I'm like, where are these courses? I was like doing GL begin, GL end, like here's a square. But anyway, yeah, I think that like for me as well, it like really my C++ programming, like actually good, I'll say, programming maybe began like when I started working at EA, and the 2 years before that when I was in university. It was very much like, I mean, like I wrote it. I was coming from Java, so there was like a lot of new keywords and stuff everywhere for me, because I was like, how do I make a new object? Oh, I'll heap allocate it, because that's the only way you do it in Java anyway. So there was like a lot of stuff I didn't understand about the language. But it's like my world completely changed when I started working at EA, because the way that they wrote code was so different to what I had been like academically taught in university. It was so like foreign almost, and it for some reason it just seemed so much easier to write code, even though they were doing more advanced things. There was almost like a sense of freedom, which is interesting, because I feel like in university it's almost like they had all these rules that were like, well, you can't do this, you can't do that, you can't do this, you know, global variables are bad, this and that is bad. And like, you know, looking back at that, yeah, like that does make sense. Like, yeah, you should not use global variables everywhere, but you should never use global variables. Like there's a difference there, you know? And I think that's one thing that working in a real kind of development environment, because when I started at EA, I immediately started on the game engine team as like an intern. So I was still kind of very inexperienced, but I was on the game engine team. And this was not on Frostbite. This was on a smaller engine that they use for like the mobile games. I was like the 7th person to join that team, and so because of that, there was like quite a lot of time that the technical director spent with me, and I think in about 2 weeks he really straightened out my C++. And that just again goes to show how much that practical experience is worth, because I feel like in 2 weeks there, just because of being exposed to it all day at work, and actually working on something serious, being thrown into the deep end like that, I learned more than in the entire 2 years of university before I started that internship, which is super interesting.
Yeah. If you do something practical, especially on an existing code base, it teaches you. It certainly taught me a lot of tricks. Like I wasn't that much of a fan of templates when I started, because templates look weird. You don't understand like from the get-go what they do. I still think that certain templates are like regular expressions, you know. You write it, it makes perfect sense, but you look at it in a month and it's like, what? Yeah, but my opinion kind of changed on that. I saw their real application, real world for real tasks, and now I'm a fan of templates.
Yeah, I think that the way I looked at templates was so different as well, because I had come from Java, and I guess university had not really explained to me that They are not like generics at all. They're way more powerful, and you can do way more things than just being like, hey, this type, goes there now, and kind of like generics, and like that's kind of it. So yeah, templates were when I learned the real power of them, it was completely different. And again, didn't do that at university.
Mm-hmm. Oh, okay. So I guess back on track. What we're talking about, advice. Oh, I was talking about auto. Remember?
Yep, that's right.
Since we are on the topic
You're
of
a fan of
templates, auto.
I said you're a fan of auto. You were saying, except for bull.
Yeah. So I guess auto is like templates light version of them, like a tiny version of templates, because type inference rules are basically the same for auto and for template parameters.
Mm-hmm.
So yes, a real world story from our code base. So the way our thing works, it obviously reads the code, it builds a syntax tree for that code, and then it uses that syntax tree to run checks and diagnostic rules. And there is a class named a walker, which basically it goes the tree recursively from top to bottom, and it visits every node. But basically, it's a visitor. It has virtual dispatch. It calls a virtual method from the tree node itself, and the tree node in turn visits something. Well, you see, the visitor, a typical one. And it was rubbish. Its interface was really garbage, because those methods which do something with different node types, they were all returning a pointer to the base class of. So the tree, it's a hierarchy. It's also a class hierarchy for different expressions, statements, and so on. And it bothered us a lot. So we decided to change that. So now it uses real types, not just the base class. And auto helped there, because you write auto everywhere, and then you change. You make a huge change. Basically, every method which is used there is changed. Everything you can touch is kind of upside down now, but your code just works. So
yeah,
you don't have to change anything in the parts of code which use those methods, which take return values from them.
Yeah.
So it's a good thing. Yeah, auto, just be careful about that, I guess, because it doesn't understand references.
Yeah.
It was, what was that? This AAA rule, right, from Jusatis? Doesn't matter. A AAA rule almost always auto, and now it's almost always auto ampersand ampersand.
Yeah.
Yeah, because that understands references and constants.
Yeah, like auto is interesting, because I'm always really torn about auto, because I feel like there are so many refactoring situations, as you were talking about, where it just makes life so much easier. But the fact that it's so easy to refactor that code, in a way, to me, also is very dangerous, because if it's so easy to make such a major change and then your code just compiles, then it's almost like, but what if I accidentally do something? And I don't know, like I definitely don't use auto as much as you do, which is, it's very interesting that you kept it for bull. I still don't really understand why.
I don't know. Bull. Just bull.
Just had to save someone there. But yeah, like I think that mostly I I try to use auto for longer types, and especially because in a lot of cases it's very obvious what the type of data is going to be from like the name of the function you're calling, and it's returning a value, and you know what it's going to be. So in those cases, I do like to use auto, but in some cases, and I feel like the more I program, the more I start to use auto, because I'm just like, well, what's the point of having all this? But there are so many situations in which, like, for clarity, I'll deliberately write the type there. I might even change auto to be the type, just because there might be like a time when I'm reading that code, and I might have been like, hang on a minute, what's being returned there? And then if I realize that I'm having that thought, then I feel like the code in a way has failed, because I can't just I can't quickly skim through it and be aware of what it's doing.
Yeah, and that's why it's important to write it so it reads like a sentence.
Yeah,
because
I like that you said that
if
as
you
well.
if you have that type of question, like, what the heck does this function return? Maybe it's a problem with the function name and not the way you get its result. It might be. Well, in some cases, yeah. In some cases, I would probably leave types. There's not many of such situations in my practice. Usually auto works fine, and it's clear what it does.
Yeah.
Especially with those things like, one cool feature about auto is when if you have like a vector in your class encapsulated inside, and you want to return iterators, you just declare two methods, like auto begin, return vector begin, auto end, and that's it. You don't even have to use anything. Like I usually write usings for types I use in classes, so I use using directives. Because it's just easier to me to use like internal types, I guess, which are declared inside the class, than something from the outside. And I used to do like using iterator, blah 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 blah. Now, if I have to do something like that, I will just write auto and don't even bother. Especially with modern compilers, which are very good at it. They can optimize code better, I believe, in some cases when you do that.
Yeah, but that, like, as you were saying, the whole reference kind of trap that has.
Yeah, reference. It's
yeah, I feel like, but I think that like because it won't automatically make something a reference, but it will make, like, if something returns a pointer, it will add the pointer, obviously, but can you optionally also write auto pointer, or is that going to be a double pointer now?
No, you can.
You can,
so
yeah.
You can write auto star, and it will be a pointer. So
yeah,
it understands how it works. So.
Yeah.
About references. Oh.
No, I was going to say that always catches me off guard, because it's almost like, okay, well, the asterisk is optional, but the reference isn't, because the reference, if you don't add it, it's not going to be a reference. So I feel like that's not the best design.
You can actually remember what's going on there quite easily, because a pointer is, well, it's like a value type, if it makes sense. So it's an address. It's an int, basically. It's a value, and reference is something weird. It's kind of the underlying value, but it kind of isn't.
Yeah.
And auto uses, basically, by default, it takes whatever you give it by copy. So it can take a pointer by copy, but it can't take a reference by copy.
That makes sense.
I think this trick kind of worked for me. It clicked at some point.
Yep. Yeah, no, that makes sense. Yeah. So yeah, I think getting back to the programming thing. So, since kind of, have you noticed like a big difference in because it's interesting, like I see PVS Studio, I see working as PVS Studio as such a meta kind of C++ thing, right? Because you're focusing on actually programming. It's almost like if you were working on like the C++ language itself, like you're focused on the code, right? You're focused on analyzing code and trying to figure out, certain things that might help developers. Have you noticed a big kind of shift in how you yourself look at C++ code and how you kind of see all of that, I guess, since you've started working there?
I see undefined behavior everywhere. Well, not everywhere, but if it happens, I will probably spot it.
Mm-hmm.
And I've become a lot more cautious about pointers, really.
Okay.
Because pointers are not your friends, even if they pretend to be your friends.
Mm-hmm.
And that's because they have that, funny state called a null pointer.
Mm-hmm.
And the compiler, well, no one will stop you from just calling a method from a null pointer. And that's UB, and that's bad, really bad, because if you're lucky, you'll just crash. If you're not lucky and your compiler decides that, okay, looks like an undefined behavior, this pointer is probably null. And as we know, undefined behavior is something which can't happen, really, because it's forbidden. Your program is ill-formed.
Mm-hmm.
So it can go and optimize it in some funny way, and you won't even notice the problem. So, well, I'm not saying that pointers are bad or anything, but I just became cautious of them. And usually, like, sometimes it happens when you want to pass a pointer to a function, stuff like that. I usually try to do references instead of pointers, if I can. So I will check it in the calling code if it's valid, and only then I will dereference it and push whatever is under it to a function or to a class or somewhere.
Yeah. So when you were saying like about the whole undefined behavior thing, what exactly about a null pointer is like undefined? Because I didn't really get that.
Well, about null pointers, nothing is undefined. It's a well-defined value. Null pointer is a valid value of an address. Well, it's not a valid address, but it's, you see. Yeah. But dereferencing null pointer is undefined behavior.
Yep.
Yeah. So as long as you don't try to dereference it, you're good. But as you try to do it, funny things can happen.
Yeah. So you're saying that like some compilers will, I guess, either constant fold or like look at certain values of pointers and determine that, hey, that's probably a null pointer, as you were saying, and that can happen.
They can do that.
Okay. Yeah.
And this whole undefined behavior thing, this is what many compilers build their optimizations upon. So if you want to optimize code, you have to prove that certain things will happen, certain things won't happen, and stuff like that. And undefined behavior gives them that, that space to maneuver more. And when they see that something is probably unviable, let's say, some code contains something that the compiler is not counting on happening in the code, they can apply different optimizations and they can screw you up in some cases, really.
Yeah. Okay, that's interesting.
So,
I know very little about how compilers optimize code. I just know that it's very scary.
It's a lot of math.
Yeah.
I'm not a compiler backend guy. I'm not a code generation guru or something. So it's kind of a mystery. I just know general stuff about that.
Yeah, right. So what kind of stuff do you do at PVS Studio?
Oh, I'm doing features
Mm-hmm.
and diagnostic rules. The latest thing, the most interesting one was the type system, the new one,
Mm-hmm.
because the old type system was really old and it it wasn't going to work anymore.
Mm-hmm.
It's still used, but I will change it. So I've developed this new type system thing to replace our existing one.
Okay.
I don't know if I should go into details or just give you an overview how it works.
Yeah, like
How to
I'm
use it
interested
working.
in yeah,
Uh,
just like an
okay,
explanation.
so yes, so you look at C++ code and you want to know obviously you want to know types of all variables and what functions return and stuff like that.
Mm-hmm.
And there are two approaches to this problem. How do you know, how do you store this information in a compiler, in a static analyzer, anywhere?
Mm-hmm.
You can use encoding as a string. You see int asterisk, so you write somewhere pi, for example, pointer to int.
Mm-hmm.
Or you can create a class hierarchy for your types and store objects and maintain links between them. So your int pointer becomes a pointer which holds an int inside, and you can ask what type are you pointing to, and it will give you, okay, it's int. And we had this whole string encoding thing, and we are running out of letters because there are so many different things you have to encode
Mm-hmm.
in C++ type system that it will bog you down. So what I did, I wrote this hierarchical. I can English hierarchical system, which will replace the old one.
Mm-hmm.
So I borrowed it from Clang, really, but don't tell anyone.
Okay.
Not entirely, but parts of it, the idea.
Uh-huh. Yeah.
I borrowed. That was interesting.
Mm-hmm.
Yeah, and usually I don't have a set responsibility, like you go do that and that's it.
Yeah.
So I can do various things.
Uh-huh.
Right now I'm working on one diagnostic rule,
Mm-hmm.
and then it will be another one, and then we'll see.
How large is the development team at PVS Studio?
Well, the entire team or just C++?
Let's go with both.
Okay, so C++ is 1, 2, 3, 4, 5, 6, 7 people.
Mm-hmm.
It's about 7 people. Other teams are smaller, and overall it's about like 30 something people, I think here.
Mm-hmm.
So that's it.
That's pretty
the
big.
entire crew.
That
kind
sounds
of.
not bad. Yeah.
Yes, and we are based in one city, so we are not distributed in any way.
Mm-hmm. Well, that's good because yeah, I'm not a huge fan of working across different time zones. I mean, it has its benefits because you can hand off your work if your team's all around the world in different time zones, you kind of hand off your work at the end of the day, and then some other time zone will pick it up in the morning. It's like a 24-hour a day kind of development cycle, but that's also kind of stressful because it's like, well, if I don't finish my work now, no one's going to be able to do work the next day in like China or something. So it has its ups and downs.
Yeah. Oh, this lockdown situation we had in working from home, it was awkward. Because I'm used to being able to, I need this guy. Oh, come here. Tell me this, tell me that. And when you're working from home, I guess in distributed teams also you have this. to talk to someone, you have to go write them, you have to start a call,
Yeah.
you have to do a lot of unnecessary things. So inconvenient. At some point I got used to it, and then the lockdown kind of ended.
Oh man, yeah, it's interesting. I saw some of my friends from EA, which I haven't worked at EA for almost 2 years now. So, but every now and then, like I keep in touch with some of the people that I worked with, and a few people have literally started working on the team a year ago, and they still have not seen the office because about a year ago, in Australia in Melbourne, like the whole lockdown situation started and everyone was working from home, and I think now they're slowly returning to the office. But that's so interesting because I feel like because I guess I quit about 8 months or so before like the lockdown started, and obviously I had no idea, but like I would not have enjoyed working from home because I in like I think 2016 I got chickenpox, and I had to stay home for like, well, a week I had it, and then another week I couldn't really go anywhere because I was still kind of infectious, and so I couldn't go to work, and so I worked from home. And it may have been the fact that I had chickenpox, but I hated it so much. It's like working for yourself from home, I think is slightly different because first of all, you can just not work, which is not ideal, but you can do it. Don't tell anyone. But then also, I guess you're kind of working on stuff that you think is kind of potentially interesting to you. You can take it easy. You can be like more kind of or like you can do various things that you might be passionate about in the period that you're sick for, I guess. So it's a little bit different. Anyway, I think we've lost Yuri's camera. You're back. Lost you for a second, but you're back.
Yeah, I lost everything here. So how do I
everything.
even? Oh yeah, put it back online.
Yeah. Did you still hear everything I was saying?
For the most part.
Yeah.
Just a couple of seconds. So when I lost connection or something happened. I missed a couple of seconds. So yeah, about chickenpox and working from home.
Yeah, I was basically just saying that like it was a total nightmare. That was my big experience of actually kind of being locked down or in quarantine. But that was back in 2016, obviously before any of this COVID stuff. So I did not enjoy that. So I could not imagine working for a year like from home, which is what a bunch of people have had to do like in Melbourne. Like that's, working from home for myself is hard enough, but then like for a company, I feel like, when you used to have a team, because I think people are different socially. Some people like to have their headphones on and not talk to a single person during their workday if they're in an office and just maybe type them a message. I was not like that. I would get up and just annoy people all the time. So I think that missing out on that potentially, and as you were saying, it's a lot easier to just be like, hey man, do you know this? Do you know that? Come to my desk, whatever. Is a lot easier, as you were saying, if you're not a distributed team with like branches in other countries or in other cities or whatever. I feel like for me that's also like a big deal, I think, to be like in an office together. I feel like for me personally that's a huge kind of productivity boost.
Oh, by the way, I know some people who really like to communicate in text.
Mm-hmm, yeah.
And they're sitting like next to each other.
Oh yeah, that's
there's
the worst.
A meter between them, and they type.
Yeah.
And I'm like, come on, you're sitting in a meter one from another, and you are talking through some server on the other end of the planet.
Yeah.
Probably, just say things like what? I will never understand that.
No, neither do I.
How?
Yeah, I don't. Oh yeah, yeah, it's a very interesting time at the moment. And the thing is, like, I would hope to say that those people who used to not talk to each other in person when they were sitting next to each other, now regretting that. They're like, I could have talked to a human at work and now I can't anymore, but they're probably still happy. They're probably even happier. So I'm not going to say anything about that.
I think they didn't notice that a change
Just didn't
occurred.
even notice.
I can still type you a message. Oh,
Yep.
What changed? Nothing changed. Things are good.
That's funny. So what do you think then? What is a definition of good programmer in your opinion? Like, is there certain things maybe that have stood out to you when looking at use cases or things that PVS Studio has detected where you're like, man, there seems to be a group of people maybe that are writing this code, but that's bad. Why do they keep doing it? Are there metrics really to measure, I guess? What's a good programmer in general?
That's big. That's a big question.
No, it is a big question. It's a very open-ended question, and I have no idea what the answer is.
I think a good programmer is someone whose code you can pick up and continue working on it without too much problems.
Mm-hmm.
So I think that can be a working definition for a while.
Mm-hmm.
I've seen bad, like quote unquote bad programmers. There are different types of people who do that. Who I can call bad programmers in quotes, and their code is always scary or too fancy or just a mess without any hint of architecture or logic.
Mm-hmm.
So usually, even if technically it's good and it works, it can be a pain to read it. So I guess being good is not about being fancy. I think many people have this misconception that, oh, I'm writing this really great complex code, which looks weird, like it's from another planet. I can write in C++ like in functional style, like in Haskell or whatever.
Yeah. Mm-hmm.
Well, you can, but think of someone who will actually work on your code after you. Mm-hmm. So what will they say? So I think a good programmer, it's someone who can write supportable code, let's say like that. And there is also a second part of it is when you know stuff like algorithms, and you can write efficient code which works fast. You can see things, possibilities for optimizations and stuff like that.
Mm-hmm.
That's secondary. That you can learn, but your culture of structuring your code itself and creating some meaningful, architecture and something which is easy to understand for other people. I think that's the primary thing, the most important one.
Yeah, no, I have to agree.
Disclaimer:
as well.
I don't know if I'm good. Okay, don't quote me on that.
Yeah, I'm used to
be good.
I used to say that as well. Like the whole, I don't know if I'm a good programmer or not. But then I realized that I feel like I've said that so many times, and I don't think anyone cares. But yeah, like regarding what you said, yeah, I think that being able to write code in a simple way is possibly more beneficial than being able to write some crazy template magic that potentially, generates some kind of internal compiler errors on certain compilers. And because the thing is, like, I have a couple stories. One of which is basically when I was at EA, and by the way, EA is the only programming job I've ever had. So if I'm like at work or at EA, then I was there for 4.5 years, and that's it. Outside of my own projects in university, that's it. So in case anyone's like, oh, back at EA is like my middle name. Yes, it's my only real job. Now I'm not a real job person anymore. But we had this problem where I literally could not compile some code because someone had written like this crazy template code that like put data together from different types and something to do with tuples. I don't really remember it too much, but it was big. And it took, I think, the technical director of the team, but another technical director and the senior software engineer who wrote that code, half the day, I want to say like 4 hours plus at my desk, because I had discovered this problem and I couldn't compile the code, trying to, dissect these templates, simplify them, see what goes where, what does the compiler output, what's happening with these types, why is it not compiling? I've been in situations as well where there have literally been like internal compiler errors from certain templates or from certain things. And then like, it's like, okay, well, maybe there's a bug in this version of Visual Studio's compiler. We need to update it. Now we need to try a different version or whatever. And I think at that moment when I realized, I'm like, why does this exist? And I asked that. I was like, why? Why have you written, because the person who wrote it was next to me, why have you written this code in this way? Like, I get that it's like, at a certain point, it feels like you've done this because it's a game to you. Like, it's a game. It's like, how do I take these templates and how do I, just pass this through so many things so that we can write the code like this in one line and it does like a billion things. And I think I realized at that time that it's not cool, it's not worth it, and it's just a tremendous waste of time.
Yeah. And I heard also a story about templates, but it was I wasn't someone who dealt with it, but I heard about a guy who was a big fan of templates and he just used them everywhere. And he managed to create a monster which broke the compiler. The compiler just couldn't chew it. So, or it was a linker.
Like ran out of memory or something.
Yeah, ran out of memory and crashed horribly. So yeah, you can go overboard with it. It's pretty easy to get carried on. But in many cases, they really help.
Yeah.
Like when we needed a way to iterate the tree, our infamous syntax tree and stuff like that, we needed a convenient way to iterate it. And we decided to create an iterator, basically, which would go. So we ended up having 4 iterators. 2 of them are, well, one of them just goes statement by statement. The second one goes like it traverses lists, like when you have something comma separated. And 2 more are basically the same, but they also provide counters. So you dereference it, it gives you a tree node and its number.
Right.
And all 4, they basically work in the same way. It's basically the same template code with some compile time, magic, with if const expr and things like that. And you just push them into a special container. Well, container, it's an aggregator object for your tree nodes. And you just go begin end, or you just push it into the for loop, into a range based for loop, and it just works. And really, there's not much code. If you look at the code for that thing, there's not much, but it does really a lot of functions for you, and it makes life easier. It's not too complex, of course. When complexity rises too high, I think that's time to stop with this kind of thing, with templates and meta programming, because you can spend all day, making all those fancy things like recursive type inference of
Mm-hmm.
things like that.
Yeah,
Yeah,
it's
but
very similar to macros, and how like sometimes you need to have like variable arguments go somewhere with the macros. And I remember trying to write my assertion macros and learning all about how we can trick the compiler to redirect to other macros if there's like this amount of arguments versus this amount of arguments. And yeah, it's a mess. But
yeah,
I think
macros.
there's a fine line, because it's interesting that you say that, like, because yeah, like templates are great. I use templates all the time. I love them. I think that, you know, some game studios I think have just outright banned templates, and I can understand that decision, but it also would really mean that in certain areas there would be so much code duplication. Where a template can easily generate all that code for you, and the template function might be like 3 lines of code. You know, it might be so simple that like, well, why not use a template here? It's not like this huge thing that, you know, goes through every latest C++ feature, and you know, it's not even. It might be really simple, and I think in those cases, it's definitely like a no-brainer. But I think that sometimes you have to ask yourself, is this feature actually complicated and, you know, difficult to understand, or do I just not understand it? Because I feel like, you know, I might, in the past, I might have been like, oh, I don't want to use templates at all. Like, they're scary, whatever. Or anyone who uses I've seen people say this on my Discord server. I've seen people say certain things like, this C++ feature is bad because no one understands it. But in reality, that person doesn't understand it because he's known about it for 2 days. And then, like, I feel like there's a lot of kind of, you know, there's a lot of that sense in a lot of programmers that, like, you know, well, I know everything. This is stupid. You know, that's dumb. I don't understand this. It's clearly too complicated. So there's that line, you know, and I don't know. Maybe some of the stuff that I'm saying these days, I might look back on in 5 years and be like, really? I didn't use this. I just didn't understand it back then.
Yeah, I used to think that C++ is becoming over bloated, you know.
Mm-hmm.
It's becoming too huge. We don't need all that stuff. Like C with classes, like Stroustrup made it, is perfect and things like that. But then I realized that, okay, so you get a feature.
Mm-hmm.
It's not mandatory. You are free to ignore it if you don't like it. But if there is a feature, there is probably a reason why it exists in the language.
Yeah.
So maybe before discarding it, go check it out, go look at it, and then maybe you will love it. So there was that moment where my opinion that really changed, and now I used to be scared of all those new standards and, wow, what are you bringing into my C++? Why? And now I'm kind of, well, okay. If it's not worth using, I won't use it. If it's great, I will adopt it, and it will be like of great help, of great use.
Yeah, no, so I was gonna say that, like, yeah, I don't understand all the people who hate C++ because it's so bloated, apparently. Like, yeah, I get there's a lot of stuff that's coming in. Like, I get it. You know, maybe I wouldn't make those same decisions, but whatever. It's going in, it's going in. I have always just used what I've wanted to use. I don't understand why people get so upset about certain things being in C++. You don't need to literally use every feature in the language. You can just use a subset of them. And I think that ultimately that's the way that C++ is intended to be used. If you are using every single feature, I think you're doing it wrong. Like, I don't think you should be using everything.
You know, if you're using every single feature, I think, I don't know, maybe you're at the university and you have like a lot of assignments about every feature in the world. I don't know. In production code, even if you're in that projects. I don't even know what subset of the language people typically use, but I would say it's no more than 30% or something.
Mm-hmm.
Well, maybe more.
Yeah, I mean,
if you count standard library, it will be less because standard library is huge and stuff there.
Of course, yeah.
A lot of stuff.
There's stuff that I've never used in 10 years or whatever. But I think that the key there was what you said about production code. Is it production code? Because I think that definitely needs to be treated differently from maybe some kind of like, oh, I have never used the C++ feature before. I'm going to try and write like a little game that revolves around it just for my GitHub or whatever. Because, when I was talking about templates earlier, there is this kind of meta programming kind of template Tetris thing on GitHub that I saw a while ago, which is basically like, it's Tetris, but every move, the program needs to get recompiled because the templates are what generate the like console output of where the pieces are on the board. So when you make your move or when time passes and the piece is falling, your C++ code has to get recompiled because that's all kind of, it's the actual processing happens at compile time for all of the Tetris stuff. So that's cool.
Tetris.
that is really like, you would never write any code like that probably in a production environment, right? But it's a really cool little repository. So it's not that I hate that stuff. It's just that if you're actually affecting people's time and doing things unnecessarily complicated, then that's bad. And going back to what you said about the fact that a good programmer is someone who can write that code in like a really nice, I guess, and simple and clean way. I totally agree. And that's something that I have learned to appreciate a lot more since working on Hazel on my game engine, with so limited resources. I've learned the fact that I need to write code in a simple way, because if it's complicated, someone from the community is going to rock up and be like, hey, can I help out with something? And I'm like, sure, man. Well, it's probably going to take you a day to get a build going because I'm using, XYZ build system that you've probably never heard of, and it's cutting edge, and you have to download this version of Visual Studio because I'm using the experimental C++ 20 features, and I'm doing, and this and that. And then at the end of that, it's cool to see the fact that there's 4 people at the moment who are actively working on Hazel with me, just from the community, just contributing. And I love the fact that they've just told me so much that like, hey man, it's really easy to pick up this engine and just start writing code for it. Because that was one of my goals, because I realized that even for myself, I'm not going to be able to handle this if I run into a template error that takes a day out of my very precious development time that I have, whilst also running a YouTube channel and, doing a lot of other stuff that aren't directly related to full-time programming on Hazel. So I think that, for sure, kind of working on your programming to get it to a point where it is clean, it is as simple as possible, anyone can read it and understand it. That is a skill that you should also focus on, not just like, oh, how cryptic can I make my code, which I think appealed to me when I was a teenager. I was like, I want to write my code in a way that no one can read it, because then that will impress like my teacher or whatever, because he won't understand it. That's rubbish. If your code should make sense.
Yes, I used to, back to my Pascal days, I used to put a lot of things in one line. I thought it was cool for some reason. I don't know. Now I don't even declare 2 variables in the same line. Well, maybe there are exceptions, but I don't do that. I declare variables each in its own line, because it just makes sense. It makes more sense, I think, than doing that comma separated initializer thing. Not initializer, declaration.
Yep. Okay, go on.
About cryptic code, believe it or not, I saw lambdas which were calling lambdas inside them. Yeah, and they were declaring and calling other lambda. So it was
That
not
sounds fun.
pretty. Yes, and optional. Oh, my favorite example is optional of variant of some types. I saw that thing also.
Oh man, I had such a big rant on a live stream about a month ago because someone had accepted a pull request into like the game engine series version of my Hazel engine, which is like a tutorial series version, so it's not like my code base, but still I'm protective of it. Where they had accepted a pull request that was like it basically added I think if you try and open a file and it returns a path to you as a string, as just a standard string. And they had changed it so that if you hit cancel, therefore nothing would be returned. So it would return an std optional of std string. And I was like, I had a huge rant about this because I was like, what strings can be empty? I was deliberately being like, if string empty or if path empty, then clearly it's been cancelled or whatever. That the actual object itself has the state. Why are you wrapping it in an optional and then having to go through all of that code? So like I think that's a good example of like, because the thing is, I know about optional. I made a video a year ago on my channel discussing optional. Like I am aware of its existence. But why would I use it if there's literally not only can strings be empty, it's not like I'm doing some weird thing like checking the memory address and being like, is the size exactly 1 byte or whatever because the null terminated character, or is there nothing there, or am I doing something crazy? There's a function called .empty. Like it's there, you don't even have to do .size and whatever. There's .empty. It's a container. It can be empty, Why are you complicating things by being like, oh, let's use this, library feature that is going to also be like thousands of extra lines of code that you're including through the header file and
some overhead also because it uses additional memory. And things like that.
Yeah.
Well, I guess it can make sense because in your case, this empty or not empty string is kind of a binary logic. So it's similar to true or false. So if it's not empty, it kind of implies true and you can use it. If it's empty, implies false. But if you want to signal like 3 states and not just 2, you can use, I guess, optional or something like that.
Of course.
So if it's either empty or not empty, or there's no string at all. So maybe, this logic.
Yeah, because of course it is possible for 0 or empty to be a valid state that might require a different response than if the data is not present at all. So it's not that I'm saying optional is bad. I'm just saying that in that case, that was a huge complication to the code because not only does it wrap string in optional and complicate that whole thing and add additional includes and all that stuff, it also means that when you use it, it's a different API as well to try and use it, and you have to use the dereference operator to get the data out of the optional and do all of that stuff.
What would have been funny if they used with that optional after? It has this method called value or. So you can ask it to give you a value or some placeholder value.
Like default value.
Use that and gave an empty string there. That would be great.
And then you can check that. Beautiful. That's beautiful. Maybe that's what I should change it to, just to spite them. Yeah. There's so many. I think that there's so many features that again don't need to necessarily exist. Which is like, have you felt like personally that there are either useless features or that the C++, because like, I mean, I've mentioned that like, I don't think that it's getting bloated because I can just choose what I use, right, in the C++ library. But are there, like working at PVS Studio, I imagine that it's not up to you to use those features or not, because you're going to be proofreading essentially people's code which will use those features. So how, like, have there been a lot of situations in which you've seen new C++, standards come out and then you're like, I can't believe we have to support this garbage?
Well, it happens all the time when a new feature comes out because especially when concepts were announced and they were described at CPP reference and in different places already. So we knew concepts are coming, and there was a point when we started using was it? It was Visual Studio 29, and it was some specific version of it. So there used to be a time when you include anything from the standard library and you have the latest C++ standard enabled in your Visual Studio, and you check that file and you crash because of concepts. They started to integrate them into the standard library, and we started crashing. And supporting that, yeah, they look kind of alien. You don't expect to see that in your, well, I expect it now, but back then they were kind of alien looking. And supporting it, yeah, it wasn't really pleasant, so to speak, but it ended well, so it's fine now. We don't crash on concepts anymore.
That's good.
That's a plus. Yeah, but I don't think there are like features which should not exist. I said before, I think that they probably exist for a reason. So if you don't know the reason behind them, well, just don't use them.
Yeah.
So that's simple.
Yeah. No, definitely. Like, I think that you
should. Except STD any. That's pure evil, as I heard.
Yeah.
Because it does some crazy stuff under the hood with dynamic allocations and things like that. So it's kind of, I think it's just a badly designed class. It's not like evil in and of itself, but yeah. So any is
I would streams.
Yes, IO streams. They are really slow.
Okay.
Well, yeah. That's not something that shouldn't exist. That's just something which could have been better.
Yeah. So like IO stream. So do you mean like IF stream and OF stream and that kind of stuff?
Everything from inherited basically from the basic IO stream or whatever the base class is called for all of them.
Basic IO stream or basic.
Yeah. So it's cout. It's file streams. They have some kind of synchronizations in them, and this makes them slow and inefficient.
Right.
I personally like for output, I like the FMT library.
Okay.
It's awesome.
It's the one that like formats your strings and stuff.
Yeah. It's a modern printf.
Yeah.
Basically.
Right. Okay.
And it's great. So it can use files and the console and anything. And it has compile time calculations built in, so you can form your formatted strings at compile time.
Okay, yeah.
Even.
Yep. Yeah, that's good. That sounds efficient. Yeah, I was gonna say something about, I think either about file
Sorry,
streams or something like that. No, it's okay. It's okay. Yeah, because I'm always like, I feel like I've been using just the C style file API and Fopen and all of that stuff forever. But I think recently I was like, okay, fine, I'll do the C++ version. Doesn't it just wrap the C style file API as far as I'm aware, or does it? You're saying it adds other like synchronization stuff to it?
You mean the streams?
Yeah. Just specifically like OF stream or IF stream.
Well, they wrap things up somewhat, but there is an additional layer to them. So yeah, they can be inefficient. But again, if you are just reading a file like if you're not doing 1,000 input-output operations per second or whatever, well,
Yeah.
it doesn't really bother you. When you start, putting a lot of things in the console, you may notice a slowdown because that's not that can be really noticeable, especially if you're trying to do it fast.
Yeah.
Not like one message a second, but 1,000 in a millisecond or something. So
Yep.
in a loop, yeah. So it will be slower than printf, and printf, I think it will be slower than FMT. I think it's the most efficient one, but I may be wrong here. Not sure.
What about just native like Windows API console outputting stuff?
Windows API? Well, don't really know about native API in terms of performance.
I kind of assume that that's probably what printf is calling anyway, right? It would have to.
Yes, most likely. Or they both call the same thing.
Yeah.
Like,
well, see, like I used to use the Windows API a lot more in the past because I think only in like C++ 17, I might be wrong on this, but I think only in like C++ 17 they finally introduced that amazing like file system API that now. Yeah, I think that was C++ 17. Now, and like again, I say amazing. I don't really care. I haven't really inspected the performance or anything like that. But from an API standpoint, it's great because, for example, you can list the files in a directory. You can create nested folders instead of just one, and then having to do that. Like there's all these kind of usability things that in the past it was like, well, I want to list the files in a directory. I have to use the Windows API. Which, I mean, there are still certain things. I'm still not sure. I haven't done this lately, but I'm not sure if, for example, you can memory map a file using the C++ kind of cross-platform API, or if you need like the Win32 API for that. But
don't know.
Those things have gotten better though in C++, which I for one am grateful for. But then again, it's C++, so I don't know what their fascination with operator overloading is. But the whole way that like now if you want to concatenate like file system paths using the file system API, you just use the / like divided by operator to just add paths together. And I'm like, I thought that was a joke when I saw that like on some code, but I don't know. They just love their operators.
Maybe it's like, oh, look, I'm typing a path.
Well, no. It makes sense. Yeah? It makes sense, but it's just a little odd to see that like in code, I guess. It's quite funny though, I think.
Yeah, it's like I saw the guy, who was that? Was that Chile? Maybe Chile. I don't know if you watched him, or do you know who Chile is? Chili tomato noodle.
I think I've seen a few of his videos.
Yeah, he's funny and he's awesome. And one of his videos, he shows the vector, like arithmetic vector, and he goes like, okay, so we have addition, it's plus, okay, subtraction is minus, that and that, cross product, which operator would I use? Oh, percent. It looks like a little cross. Makes sense. Yeah, it makes sense. So, well,
that's funny.
But when you see like one vector percent another vector, what's going on there? Is it modular division?
Wow. What? That's ridiculous. Yeah.
So, yeah, operators, you can go crazy with them.
Yeah, there was
you can easily go crazy with them.
Oh, there was some. I don't remember what this was, unfortunately. I don't know. Maybe this was a boost thing, but there was like some serialization library, and I think they used the ampersand. Well, it wasn't. It was like
it was boost.
It's like a bitwise and the bitwise and I guess operator, because it's not like a reference thing in between two things to put objects into a stream or whatever.
Yeah, I think they also use some other operator, maybe in this pipe thing,
yeah,
like or Well, and again, streams, input streams, they use the left shift and right shift
Yeah.
to, write and read. But that makes sense, really, because you are left shifting something into a C out. Probably you want to
You're
write it there.
pushing
Yeah,
it.
pushing it.
You're
Yeah.
pushing it into the that's how I see it. But that was interesting because when that was one of the weird things when I was coming from Java into C++. Obviously, the first thing you learn about is how do I print "Hello World" to the console, and it's like, oh, and then I was like, because I was doing like software rendering algorithms and stuff in Java, so I was very much aware of like the bit operators, and I was like, why is this what is this? How is this bit shift left? Like I literally spent like hours, I think, being like, is this some kind of weird mathematical thing that I'm not getting? Like, why? How is the string being bit shifted into the output stream? Oh, that was good times. Oh, that's so cryptic. That's the thing. Like you C++, hello world, and you're already like, what is happening with this? Why can't I just do system.out.println or console.writeLine in C#? It's so simple. And then C++ is like, well, you need to, shift this left into this place.
Yeah, it can be difficult. When you see it for the first time, it will put you off guard. Right?
Yeah. I feel like that's almost a fair introduction into C++ and just how flexible and crazy it is. Yeah. No wonder some people are like, I saw on my Discord the other day, someone was saying that like C++ is bad. I'm tempted like every day to rewrite my entire engine in C99. And then people were like, "Oh, what? Like really? Why C++? You want to rewrite your whole engine in C? Like why? What's so bad about C++? I don't know. It's terrible. I hate it. And there's like it's interesting because I mean, segueing from what we were talking about the terrible Hello World example, like sure, but apart from that, I just feel like there's so much negativity around programmers, and I don't understand. Like, there's this culture of just hatred towards everything. There's like, there's superiority. There's like, I know everything. There's I hate everything. Like, how have you come across like that kind of culture a lot? Like, what's your experience with this? What do you think about that?
That's a common thing from my experience. It's almost a good, it's almost a part of the quote unquote good behavior to hate on some other language or whatever. Or, those web developers are stupid, or those, I don't know, those C++ dudes are masochists. You have to manage your memory all the time.
Yeah.
Yeah, so C++ developers are masochists. How do you use that? You have to manage your memory. It always leaking memory. Come on, dude. Unique pointers are for you. You don't have to do anything really.
Yeah.
So it's, I don't know, maybe it's just our thing. Maybe that's what we do. Like you crawl up in your little cozy niche, and then you look outside and, ooh, that's bad, that's stupid, that I hate. So I don't even pay it. I don't even pay attention to that anymore. So
yeah, no, everyone seems to have really strong opinions, and I feel like I don't know. I feel like when I see that these days, maybe I've just grown up a bit more, but I feel like I value like respecting people a lot more, to be like, okay, if you want to do that, like that's cool, like you're allowed to do something different. So yeah, I mean, again, maybe I'm in a position where I'm just looking at my YouTube comments all day, and then people are just being like, "Oh, I can't believe you did this. I used to watch your videos, and now you've done this or whatever." Or there's just like, yeah, people, and again, I've got like almost 20,000 people in my Discord server, and so the amount of hatred that I see there sometimes, it's like my moderators are just outright banning some people for being toxic because of the whole disagreement thing. It's kind of a shame.
Oh, well, I guess that's inevitable because you just cannot make everyone be respectful and civil and stuff like that.
Yeah.
That has always been, that will always be. So we just deal with it and move on.
Yeah.
So I don't think I really don't think it's that huge of a deal as like all this, hate and stuff like that. Because
Mm-hmm.
if you're on the internet, you can just, I don't know, close the chat window or ban them or unsubscribe or something.
Yeah.
If you come across someone really toxic and you just ignore them,
Yeah.
basically. That's what I do.
No,
Anyway.
no, it's good advice. You have to just find a group of people who are actually respectful, I think. Instead of just being put off like programming or whatever forever. In fact, you just anyone out there who's watching this, if you need someone to talk to about programming who's not gonna just hate you, then just send me a message. I'll try my best. Because that's one thing I am passionate about, like is and one thing I really hate is all the hate. And hate plus hate is like two negatives, right? It's a positive.
I think you have to multiply them.
Yeah.
Get a positive from two negatives.
Exactly. Multiply the hatred.
By the hatred.
Yeah.
Hate multiplied by hate equals what? Love.
Yeah. Love plus hate plus hate. Not hate. Hate times hate equals love.
Yeah.
Perfect. We solved it. Yeah. What were we talking about before that? I think I was saying the whole Discord thing and C99 and people hating all the features.
Oh yes, C99 new features.
Yeah, I think it was just mostly about my point with that, I think, was just mostly about how a lot of people do like to hate on C++ and think that, we need a new language, or, we need Rust, or we need Jonathan Blow's new Jai or whatever programming language to write games, and I refuse to write a game until that language is out because that's the reason why my game isn't working. Or like, all this other stuff. Like what do you think about, like, is C++ really that bad that we are you looking forward to a replacement? Like, what do you think about that?
Well, if I thought that C++ was bad, I wouldn't have been here. So
okay.
yeah.
Point.
No, I really don't think it's bad, and I don't think that any replacement is really necessary. If people get put off by the difficulty of the language, well, you can use a simpler subset, and you won't see all of that complexity will go unnoticed, basically, in many cases. Some people are still afraid of that, memory leakage, too difficult to write code, you have to manage everything yourself thing, which is also not true anymore. With the new standard library features, new. So I think the language is becoming more like it's becoming safer to use on the one hand, and on the other hand, believe it or not, I think it's becoming more beginner friendly. Just to make it completely beginner friendly, you probably need to enter it from a certain angle and use like some small subset of features, because if you try to understand the entirety of the standard library or templates or anything complicated when you are a beginner, you will fail, obviously. But if you just something small, throw in some STL there, like unique pointers to prevent your memory from leaking and to prevent you from complaining about oh my goodness, I forgot to free that memory block.
Mm-hmm.
I think you'll be good, even if you are not a C++ guru or something like that.
Yeah.
So yeah, I think it's in some sense it's even becoming easier to use and easier to learn in some sense, in
Yeah.
some small areas.
Yeah, no, I definitely I agree with that, and I think that one thing that separates a lot of other languages is their libraries, right? Like C Sharp, for example, I've really liked C Sharp because their library is so good. Like the library is huge. It's very kind of similar to Java, I think, but in my opinion, C Sharp's a lot better than Java. But that might be controversial for some people. But
Holy War.
what?
Holy War.
Yep. But I think that like C++'s library in the past, like as I kind of brought up that example earlier with the file system API, how you can't even list the files in a directory before C++ 17, as far as I'm aware. It's getting better. Like you can now, right? But I think that a common misconception is that people look at C++ as the same kind of language as Java or C Sharp or something else, and then they're like, oh well, what do you mean like there's no build system, or what do you mean there's no that thing? And my kind of opinion and the way I look at it is that C++ is supposed to be fairly bare bones. Like if you want a build system, you have the flexibility to decide what build system you use, or you can write your own build system. That's not something the language offers, but that and again, they're going to change that potentially, but that's not something the language offers because it's flexible. You can do what you like, but if you expect it to be this kind of language that you can easily write, all of this code in a matter of hours and everything builds nicely and everything it does everything automatically for you, I think that's not going to happen, and that's definitely a bad way to look at it.
Because it's a low-level language.
Yeah.
In the end of the day, it's not an assembler. It's higher level kind of than C, which is an assembler with a human readable syntax.
Yeah.
I mean, yeah,
exactly.
kind of like that. But still, it's a low-level language.
Yeah.
It's not something you will use for your high-level stuff. Like if you need a quick and dirty UI application for something, if you need a website, if you need I don't know, some quick solution for some data processing or anything like that, you won't probably use it. But if you have the foundation which allows you to do certain things easier, you can still use it for even those tasks.
Yeah.
Well, if we get the network library in SCD, that would be great.
Yeah. That's still something I think that's missing, that's present in Java and C Sharp.
They have a technical specification for networking.
Mm-hmm.
So maybe it will get into a future standard.
Yeah, that would be good.
We are definitely getting modules, which will be like, I don't know, like Java packages and things.
Yeah.
Well, not exactly, but it will be similar. Yeah. It will become easier to get dependencies for your application.
Yeah. I hope that works out well because I'm a bit skeptical, but we'll see.
Well, usually if you read descriptions and articles from people who are involved in making this kind of stuff, or who have, let's say, early access to features, they are usually optimistic. So yeah, we'll see. When it releases, we'll see.
Yeah. Yeah, I mean, it's interesting. There's so many features, but I feel like there's so many things, like you were saying about networking. So many things that are missing still. But to kind of reiterate what you were saying earlier as well regarding the fact that if you are a beginner learning C++, you shouldn't be using all the features and trying to look at what's interesting about C++, I think, is that it's so, and that's one of the things that I love about it, is that it's so kind of it's so free, it's so flexible. You can write C++ code really however you like, and you can use this, you can use that. You don't even have to use like object-oriented programming or classes or methods or inheritance or whatever.
You can go C style with it.
Yeah, you can do anything you want, really, right? And that's so cool to me because I feel like it can morph into whatever my programming style is, and usually it's a blend of a lot of styles. Like I don't want to be stuck in object-oriented programming mode, because that's very limiting in some cases and not very performance friendly, we'll say, in certain cases. But then I also don't want to be without that because I like that sometimes and it makes sense. So I think it's really cool for that, but it also means that if you are a beginner learning C++, you can look at two code repositories and they won't look like the same language, and that can kind of be difficult as well, I think.
Yeah, especially when people overuse those modern features like templates, lambdas. Well, templates are not modern, but let's say it's kind of stylish.
Yeah.
Yeah, really, you can look at two different code bases and you will see absolutely different tricks they use here and there, and the architecture will be different. Somewhere it will be a lot of template classes on template classes in template classes. Somewhere you might have, I don't know, free functions and lambdas everywhere or something. So yeah, it can become crazy.
Yeah. But as you were saying as well, I think there are so many useful things there that definitely should be almost standard when you're beginning. And you mentioned unique pointer. Yeah, like that's a really good example of one. And one thing I tell some of my students as well is okay, maybe you don't understand what it means, because first of all, like unique pointer is a weird name, I think. I would probably call it like scoped pointer or something, but like it might not be something that you understand for certain, if you're a beginner, but try and write your own unique pointer. It's very easy, and it teaches you a lot about stack allocated objects in C++ and how, you can use the constructor and destructor to your advantage in a scope. Because especially if you're coming from Java with a garbage collector, and you allocate an object in using the new keyword in Java in a scope, well, that's great. That doesn't teach you much. But in C++, it's very, very different. And I think that's a really useful lesson. And not to mention as well, there are so many, like unique pointer, like fine. You don't really you don't need to use unique pointer. I would highly recommend everyone does. But you don't need to use it. You can just delete something at the end of a scope manually. Like you can do that, right? It's just automating it for you. But there are other things that you can't really live without. And like a good example, I think, is shed pointer, like having a reference counting system, right? Because in certain situations, you don't know who's still holding onto an object and you don't know when you can delete it. Like a really good example, I think, for all the game engine programmers out there is, what if you have like kind of a render command queue or a render thread, right? Like, how do I know if I might be done with my texture on one thread or on one kind of area in my code, but there might be other things that are still dependent on it. For example, maybe the frame that needs to render with that texture data hasn't been rendered yet. How do I know when I can delete my texture from memory or from my GPU memory? Like, that's a really good example of like, well, if you use like a shed point, I mean, we don't use shed pointers in Hazel. We have like our own reference counting system, but that concept of doing that, and shed pointer provides you with that in the C++ standard library, means that you can actually physically do things that you couldn't, like, you can't just manually delete something because you don't know who still owns it. So there's so much useful stuff there, definitely, that even as a beginner, I think, those tools are kind of there, and that's, to me, the spirit of C++. they provide you with a language, but there's so much stuff you can build on top of it to make things easier. It's almost like Minecraft.
It's like
I don't know why I'm comparing it to
yeah,
that.
a box of Legos. I don't know.
I was gonna say like Minecraft, and you can chop down a tree and build a wooden pickaxe, and then you can use that to get stone, and then build a stone pickaxe, and you kind of just you build you're supposed to, in my opinion, build tools on top of C++ to help you write code. And I think the library does a decent job of writing with it.
That's true.
Yeah. I saw someone in chat was saying, do you have any career advice?
Career advice?
So like if someone wants to get a job as a C++ programmer, I assume, like how would you recommend they go about that?
Well, how I went about that myself, this I can tell you. I'm not an experienced, really experienced dude. I talked about it at the beginning. I just coded for fun, and then my job I was having at that time, it kind of bored me. I burnt out, and I decided to find a new one. And I looked up what was available, and I'm like, static analyzer, C++. That's interesting. That's what I like. Let me try it. And to my surprise, I passed the interview kind of easily because I had experience at that point. I'm not like, I think I'm not the guy to whom you would go for career advice, really, because I'm not that experienced in this all this stuff.
Yeah, I mean,
I would say learn. Sorry.
No, go on.
I would say learn algorithms, at least basic, and data structures, because that's the big one everyone wants to know about. And don't be afraid to code on paper. Even try it. That will help on the interview, because that's common stuff. People will ask you in many cases to write something without a compiler and without a computer.
Yeah, I actually used to really enjoy those. When I was in university, we had certain exams and we had to write code on paper, and everyone hated them. But I really liked them, and I think it's interesting. Like, there's a little story that I think I've told before. Certainly not on this podcast because this is episode 1. But when I was learning programming, when I started learning programming, I was about 16, and I was really interested, as I mentioned, in like software rendering and like ray casting kind of algorithms and stuff to generate like a Doom style game, just in software. And I was so interested in that I printed the code. I printed the code onto paper. This was Java code, and I took it with me because we had like a school camp. And so we went away basically for like 5 days. We went camping with like my friends from school, but this was like actually like school had put on this camp. In schools in Australia, like it's very common to basically every year, starting from like year 4 or something, when you're 10 years old, you go camping like every year basically, and you learn like survival skills. And I guess Australia is, you need to be able to like survive. But no, it's really fun, and I'm really glad that we do that. But so I was in this school camp in year 11. I was 16, and I had this display folder of display. This sounds ridiculous. Display folder of like Java code, of like rendering and stuff. And I had just started learning. I was maybe like 2 months in. So this was 2 months of me programming like at all. I had not written this code. I was looking at someone else's project. I had printed it, and I was basically at night at the school camp with a flashlight. I was with a torch, I was looking at the code and I was reading it. I was trying to understand it because I couldn't really, because I had barely started programming, and here's this huge thing. But the point is, like, I don't know, I was so passionate about it, and maybe because of that, I was totally okay with then writing that code on paper, Because the other thing that I would do, and again, I don't know why. I guess I was a teenager. I had no one to mentor me. I was learning completely on my own. My teachers in high school, my IT teachers in high school, actually, one of them, my IT teacher, told me when he caught me looking at Java code in class, and in IT in high school, they didn't teach us programming. They taught us like a little bit of PHP, maybe a little bit of web programming, but a lot of it was just databases and Microsoft Access, I think. Just rubbish, really. And so he told me that I should stop looking at programming in class because it's never going to amount to anything. So unfortunately, I never saw him again after I quit high school, because I would love to go back and be like, actually, I think my programming has amounted to something. But anyway, the point being that I had no one to mentor me because no one in high school knew programming, apparently. Weird. I don't know how. But one thing I would do very often is I would kind of learn to create this little engine in Java that could render and rasterize pixels. And I would literally come home from school and start a new project almost, I feel like every night. I don't know how, probably not every night, but I did this, I feel like, for months. I would start the project from scratch and I would try and write as much code as I could off the top of my head without using any resources. And again, it's a bit weird because it's like, well, wouldn't it be better to just progress the project? And the answer is, yeah, probably. But for some reason, it really appealed to me that I could put on some cool music in the background and just write code and make stuff happen from my mind, I guess. And maybe that's why when the exams rolled around in university years later, I was like, well, okay, I can write code on paper. And I still maintain that if you sat me down in a room, I could probably write a decent OpenGL renderer. Definitely not Vulkan. Definitely not. But I could write a decent OpenGL renderer from scratch on paper. And I'm sure there'll be syntax errors or compile errors and certain things here and there. But mostly I could do it because, I don't know, like I just feel like that was kind of ingrained in me. So yeah, programming on, what you were saying, writing code on paper for interviews, learning data structures and various algorithms. I think that's really useful as well if you're trying to get a job, because it will teach you a lot about the language. And it can potentially be an incredible platform for learning more about optimization and how the language works as well. Because I still remember how the technical director from EA was helping me with a university assignment. And he was my boss. And basically we had to write this like breadth first search algorithm. We had to compare it to an A star search algorithm and then be like, see, this is why A star is faster. But he had sat down at my desk one day and he was like, all right, what's this rubbish assignment you're doing? Let's blow this out of the water. And he had basically written it in such a way and that there were no heap allocations, and that it was all just perfectly on the CPU cache, which I didn't know what that meant back then, but it was just perfect. And it was so fast. It went down from half a second to 4 milliseconds, I think. It was so fast that my teacher almost failed me because he was like, this isn't working properly, because it was faster than the A star, because just brute forcing all of that data, which was perfectly on the cache with no allocations, was faster than doing all of the operations you needed to do and all the mathematical things to actually figure out the shortest path and all of that stuff. So my point with that being that, there's a lot of stuff you can do with data structures and like with algorithms, and there's a lot of, it's almost like, there's YouTube videos that's like, baking a cake, from beginner to expert, or 5 different, 5 ways, like explaining quantum computers in 5 levels of difficulty or whatever. Minutes. Yeah, and it's like he's explaining it to like a child, someone like a teenager in high school, university student, a PhD student or whatever, and it's like different levels. I feel like with C++, like you can take an algorithm or like, something like breadth first search, and you can write it 10 different ways potentially, and like you can just use that as a platform to learn more about optimization, learn more about memory layout, learn more about like why allocations are bad and certain other things. So yeah, definitely, I think good advice there.
Just don't I don't know if I think it was inspiring what you just said. I really do. Just a warning to people who might be over-inspired a little bit.
Over-inspired.
Yeah, you can. Yeah, you can do a lot of things and squeeze a lot of optimizations by using certain tricks, like by using CPU efficiently and so on. But in the general case, you shouldn't use a less efficient algorithm just because it's more CPU friendly or stuff like that. Because after some point, the algorithm efficiency beats optimization, if you know what I mean. So there are situations when, for example, you can do a bubble sort on a really small data set and it will be perfect. It will be fast as you won't believe. But you give it a larger data set and all of the sudden it will fail.
Yep.
Because of that big O notation and the rate of growing
the time complexity scale.
Yes,
it doesn't scale well.
Yeah, so because of that, certain algorithms will fail you no matter how optimized they are. So that breadth first search, I think, I think there wasn't a huge graph, right?
No, I mean it was like maybe it was up to 1,000 different 1,000 nodes or something. But for sure, of course, if you try and scale that up, it's gonna be very apparent that A* is a lot better. But I guess the point it was to learn about those limitations, and also again, I think challenging yourself to optimize breadth first search instead of just because you can implement it just as a beginner one way and it can work, but then potentially taking that further and learning a little bit more about like, oh, so that's how memory works, or this is fast or this is slow, and maybe I should try and actually care about how my memory is laid out, or all of that stuff. Another actually really good example, this isn't really like an algorithm, it's very simple, but one thing that I learned very quickly when I was doing like software rasterizing stuff in Java was the order of my nested for loops, because I noticed that in a lot of the code I looked at, the outer loop was always like for int y equals 0, y is less than height y++ to like fill a buffer. And then the inner one was for int x equals 0. And I was like, I wonder, because that reads like, y first and then x. And I'm like, well, wouldn't x, y make more sense? And I still wrote it like, I didn't write x in the outer loop. I wrote y in the outer loop and everything was fine. But then one day I tried it the other way around and it was like half the performance. And then I think at that moment I learned that, well, yeah, if I'm writing a value into a buffer, skipping the entire, kind of going down the column instead of going across the rows, then I'm getting like a cache miss every time I write the next value in. And that I think is a really powerful example of how kind of trying to optimize, I guess, certain algorithms, because the result is the same. It's the performance that's different. Learning how to optimize certain things in that regard can actually teach you a lot about how the language actually works and how computers work. And I think C++ specifically does a really good job about teaching you how computers work.
Yeah, yes, you can say that. I think if you don't care about it's not. Well, no, memory layout is also important. It's more how CPU works. That's what you should be concerned about. Yeah. And contiguous data is always better than anything else.
Definitely.
That's why std vector is always the best choice, right?
Yeah. No, like I'm
not always, but yeah, you should prefer vector and
over
then
like list.
use and then use something else if vector doesn't really help you.
Yeah, vector and like unordered map, I think, are probably my top two most used things.
Mm-hmm.
I use map sometimes, like usually when I want a sorted data set. So like a good example is recently material sorting for like certain materials you might want to render. They physically need to be rendered after. So if you have a transparent material like glass, you need to render that after you render opaque materials. Otherwise there'll be nothing to see through into. So like you can use like, sometimes I put materials into maps that are sorted, because then that way you've got a sorted map. So map is also sometimes used, but unordered map I think is just, great. Obviously it's a hash map. And then vector. And then, yeah, like a lot of people ask me, okay, but what about the other data structures? I'm like, what other data structures? Because like I feel like 99% of my use cases, usually, at least in the type of programming I'm doing, falls into unordered map, and way more commonly than that, the most common is vector. And yeah, there'll be like unordered set and stuff sometimes, but like mostly that kind of stuff. Yeah, contiguous memory, definitely important. And also, order one, I guess, lookups for the hash kind of stuff is also very powerful.
An ordered map, I think it has a catch there. If it runs into collisions, you may end up running quadratic time, rebuilding the entire underlying structure. But still, it's so good that, okay, yeah, once in a while, maybe one operation will screw you over. But
yeah,
most of the time,
We'll
it's
forgive.
great.
We'll forgive it.
Yeah.
We'll forgive it because it's good. Someone from chat asked why std vector is better than std list. Do you want to answer that?
Sure. That's because the vector stores its data in a single memory buffer inside. So it's a contiguous area of memory. And to address it is very efficient because data is located like one value after another. So CPUs have a much easier time working with that. If you use a list, every item in the list is somewhere on the heap. And nobody guarantees you that they are located anywhere near each other. So every time you read an item from a list, you are addressing somewhere into the memory, and your CPU goes to work really hard at that point, because its cache is invalidated because you're touching some cold data somewhere in the memory. So that's why a vector is more efficient.
Mm-hmm. Yeah, I think that a nice little example that I had about that, this isn't to do with vectors directly, but what you said about cold memory, meaning memory that hasn't been recently accessed and that isn't part of the memory that the CPU may have fetched. One other thing that I was shown as well at a point was that sometimes it's faster to recalculate data than it is to cache it and retrieve it. So I had a situation, I think, in my Sparky game engine, which was a game engine I wrote like 6 years ago, where I was calculating, I think, offsets for a string, or I was doing certain font metrics or doing whatever. And so there were a lot of like additions and subtractions, those kind of operators, basic math operators, add, subtraction, or whatever. And I had the idea at one point, I was like, okay, well, that's dumb. I'll just add these two numbers together and I'll cache the result somewhere. And then I discovered that, well, actually, it was slower to retrieve that cached data than it was to simply add the numbers again. First of all, adding numbers is ridiculously fast. It's not, but a cold memory read, and that's what I think is really important for people to understand. Accessing memory also has a cost, and potentially a very significant cost. But adding two numbers together, usually, that's significantly cheaper than having to fetch memory which you actually didn't already have nearby in a decent cache. So I think that's something that definitely and that's again as Yuri said, that's why vectors are good, because the memory is tightly
especially
together.
when you're doing calculations using some values on your stack, because the stack it has huge chances to be a hot area. So you are always doing something with the current stack, and the CPU will have much easier time writing there. The only drawback of the vector is that if you reach the maximum capacity and you add a new value, it will reallocate the entire buffer.
Yep.
But vector is also smart, so it won't give you like the number of elements plus 1. It will give you like twice as much after the reallocation. So it's not a huge deal. Or you can use reserve. And
reserve, resize, both very good. And I think from memory, at least the MSVC kind of implementation of vector will allocate 50% more, I think, memory. So if you have like 12 elements, you add one more, it'll do like 18 or something. So yeah, it will reallocate a bunch more, and you can, I think, control that as well if you want to pass in an allocator. But anyway, had something I was going to say about vector. Oh yeah, and then also so there's two costs. There's the whole, as you mentioned, reallocating the buffer, but then there's the I need to get my data from the old buffer into the new buffer. And so it's I think it used to be just copying that data, I think, at some point, maybe before move semantics. I don't even know how that used to work. But now obviously it will try and move it, if possible. If you've written a custom class with a proper move constructor and everything, it will try and move it, which could potentially be a lot cheaper than I guess in the past it used to. Like if you had, like, for example, a vector of strings, did it really used to, it just copied? I guess it would have to copy everything, which could be a disaster.
It would copy everything and allocate their internal storage as well. So now you're just stealing underlying resources and placing it somewhere else. So it's move semantics is one of the examples of great improvements, I think.
For sure. I agree. I think now looking back on C++, I feel like it was a scary world before move semantics, because I feel like there's so many cases in which it just speeds up your code. Because you don't need to copy.
Oh, and now we have one more wonderful addition is copy elision and return value optimization, which are wonderful. You can return objects by value from functions and not be afraid of any cost, basically, because in some cases your compiler will be able to do it at literally zero cost by just constructing the object right there at the call site.
And I think, like, though that's actually one of the reasons why for return value optimization, definitely that's it's really valuable. But then also I really like using in place back, like with vectors. I feel like I do that so often. I'll just, and a lot of the time I'll do it with no arguments. I'll just do like vector dot in place back, and then I'll assign that result to like a reference. So I'll have like object reference blah blah equals that, and then I can, like, it might be a struct, it might be like just a struct, and then I'll fill that like with data or whatever. It's not really construction in place, but I think last time I checked, at least it's and this is one of those things with C++, I think, that sometimes you think you might be doing the right thing, but you might not be, because I feel like there are some, I remember profiling this, and there are some situations in which copying memory I remember and again, I don't remember the details of this, and this is why I always tell people this. You need to test stuff. Like anything we say on this podcast, first of all, could change. Compilers become smarter. You know, C++ adds so many crazy things. In 10 years, I feel like it'll be even weirder. Like stuff can change, obviously, but also it depends what environment you're running on. It depends what compiler. It depends what platform. It depends what CPU architecture. So many things are kind of up in the air here. But I remember a few years ago, one of the things we had was we had like a matrix, like a mat4, so 4x4 matrix, 64 bytes. And we were passing it by const reference. And we discovered that if we did it was at maybe there were a bunch of them flowing into the function or something. But if we changed it to be by value, it seemed to perform faster.
I see. Yeah.
You can give some insight on that?
Oh, yeah, because referencing something by address is again going somewhere in the memory.
Mm-hmm.
And it depends on the size of your object.
Mm-hmm.
I think on x64-bit architectures, if you have like an object of about 4 pointers in size, about 4 pointers, I think. So meaning 64 bytes of 32 bytes. Yeah. If you pass it to a function by value, it will go directly through CPU registers, and it will be faster than referencing.
Yeah.
For relatively small objects, passing them by value is better than referencing them.
Yep.
That's why, I started doing that a while ago. If I have an object like, maybe 3-4 pointers in size, I just push it everywhere by value, unless I have to modify it wherever I give it. But yeah, if you just need to read it, you can safely use by value data passing.
Yeah.
And my video is so slow for some reason. It's lagging.
A little laggy. It's okay. It's not too bad though. I was gonna say that and obviously it also depends if the object if it's just a struct of data, then that's fine. But obviously if it has like heap allocated memory backing it and copying it would thus, actually have a copy constructor that does something like allocate memory in the heap, then yes, that would be bad. But other than that, if it's just kind of a pod data type, I guess, plain old data, then it's then sometimes it is a lot better to pass it by value, which is interesting. And again, one of those things that I feel like I learned recently.
Okay, and I really think we got a memory leak in Discord because.
Really? What's your memory at?
I really think I've ran into a memory leak in Discord or something because it's crawling for me right now.
Yeah. What's the memory usage? Does it say?
I don't know. Maybe it's the laptop here. Let me check it.
Mine seems pretty okay. I updated mine before this podcast just to
mine is fresh, freshly installed. Let me do that. Just a second. Sorry for that.
Yeah, no worries.
Maybe something else is.
This is a good time, by the way, if anyone in chat has any questions, then maybe this would be a good time. I'll read chat now and I'll see. It's one of the benefits of having the podcast live.
Yeah, it helps you kind of deal with unexpected situations.
I think someone earlier asked, should you always prefer to use standard array instead of vector? And I think that like the difference between the like std array and std vector is just that std array is kind of like a normal kind of C style array. Like it allocates memory on the stack. Like you just create it. It's a stack allocated blob of memory, which obviously is an array of X amount of elements that you also have to declare at compile time because it's all stack allocated. Whereas vector obviously is heap allocated. So I guess like the first answer to that is it depends if you need the array to grow or not. That's usually the answer they teach you in university. If you need a growable array, a dynamic array, then use vector. If you need a static array, use std array. But the much deeper, I think, answer to that question is it's also very valuable to know where the memory is coming from. So stack versus heap. Sometimes it's easier to be like, okay, well, I have an array. It could be like I have a bunch of values. It could be 3. There could be 5 of them. There could be 10 of them. I guess I'll use a vector. But in reality, maybe you should just allocate an array of your maximum size, like 10, and then just use that. Because if it's on the stack, it's going to be faster. So, whoa, let's try to adjust my headphones. They almost fell off. But yeah, my point being that that's a good example, I think, of it. It helps to understand the behind the scenes of like what's actually happening rather than just like one of them is resizable, one of them is not. So yes, you should prefer std array if possible, but it also your camera just disappeared. It also
it just broke again.
Yeah.
I'm back.
Okay, I switched to my camera. Sorry. Yeah, it also very much depends on things like lifetime. You know, do you need this to exist? You know, outside of the scope in which you're allocating it. Do you need, you know, how big is it going to be? Because you don't want to wind up with like a Stack Overflow exception. There's a lot of kind of considerations there, but mostly it's just that yes, if you can, you should use std array because the memory is better memory.
By the way, can you see me now?
Yep, I do.
Okay,
everyone sees
something weird is going on here. I think it's not Discord, it's the laptop doing weird stuff.
Yep. Yeah, we're coming up on 2.5 hours now, so
yeah,
probably a decent time to start wrapping it up. I don't know how you're doing on time. I was meaning to ask you before this podcast started how much time you had available, but I guess I forgot.
It's okay. Don't worry.
Yeah. Okay.
It's not like I have to do something urgent because everyone knows that I'm in the office, by the way. Everyone knows that I'm going on this podcast, so
yep.
It's sanctioned, so it's not really a big deal. Except it's 4 p.m. right here, so maybe we actually should start wrapping up.
We'll start wrapping it up. I was gonna say you're here doing the podcast. Everyone knows that, and meanwhile, everyone else, because you're in your private room, everyone else in the office is just sitting at their desks watching the podcast.
I don't know. Maybe we'll figure it out because they very much could do that.
Yeah. I was gonna also ask you if there's because you mentioned obviously about like personal projects and stuff. So is there anything you're working on outside of your job that's like really interesting that you maybe like to share?
I used to do that. Then I went all perfectionist and I privated my GitHub repositories in hopes to, make them looking better.
Yep.
So currently it's like, it's like hidden. So because I really, I have this kind of a perfectionism sometimes. Sometimes I'm overly critical of what I'm doing. So if I see like, oh, I don't like this, this is garbage, this is wrong, I need to redo it, I may hide it under a rug and then put it back when it's redone. So right now my GitHub is in a sorry state.
Yeah.
So I don't think it's worth looking at. I think all it has is a CMake template kind of, which I made to to take it and use it
Yeah, right.
for new
But
projects
but more so
because I
like what
decided to
kind
use
of
Teamlink.
stuff were you working on, I guess, or like do you have
Well,
anything interesting like just to
okay,
talk about, not necessarily share the code too?
I'm excited about AI and stuff like that.
Okay, that's
Game
cool.
AI,
Uh-huh.
mostly, not true AI.
Yep.
So true AI is exciting, but it's out of my league, I think. Well, so yeah, I had experiments in that. I had autonomous agents running the cockroach thing I mentioned. And then I had, still have the game engine kind of thing,
Right.
which
Yep.
has what I did there. I had an input system with controllers and keyboard and mouse and stuff like that. I had events for input, and not only for input. I had rendering. I think I could just, the point where I got to was just load a model in an object file and display it and rotate it in different ways. Yeah. And also it had some options, custom options system which parsed some configuration files. I'm planning to return to it. But not right now. Not currently.
Yep. Yeah, cool.
The cockroach, especially, I wanted to make a behavior planner for it.
Oh yeah, right. Yeah, the cockroach stuff definitely sounded interesting, especially when you contrasted that with Space Invaders. It's like, yeah, so I did Space Invaders, and then I did Cockroach. Cockroach was that sounded interesting. Cool. All right. Well, yeah, I guess we'll wrap it up there. There are a few other questions that I don't know if they're worth answering or not. You know how I feel about your guys' questions. Usually they're rubbish. I'm kidding. Love you all. Someone's saying that do you think OpenGL is a good place to start with learning 3D graphics? My personal opinion is yes. I think that I actually talked about this in a video recently on my channel as well, that I think that OpenGL is because the API itself is kind of simple and it abstracts away a lot of the driver kind of stuff that you need to actually do. You can focus more on the actual code to render interesting things rather than like low level stuff like synchronization and memory and stuff like that. So I think that if you're after learning about graphics programming, OpenGL is going to be it's going to be a much easier time for you, and you're going to actually be able to spend more time working with the graphics. Have you done much graphics programming outside of like the engine stuff you're working on?
You mean me?
Yeah.
I was I wasn't diving into APIs really. I used that Windows thing again, GDI, drawing on a window. That's because I wanted to get a feel for architecture first, and then write different renderers. So I decided just to use something simple first. Well, it was simple, but of course it's difficult to persuade it to do something really good. So yeah, maybe that was a mistake. Maybe I should have started with OpenGL or DirectX or something.
Yeah. DirectX is also a decent start. DirectX 11 specifically, I think. DirectX 12 is very similar to Falcon. But DirectX 11 is a little bit lower level than OpenGL, but it's the API is very nice and the validation is good. Microsoft's tools are brilliant, definitely better than the OpenGL tools. So that's a good start as well. But again, like you'll quickly realize if you start doing that kind of stuff that doesn't really depend on the API too much. It's more about how you're processing the data, what you're doing in your shaders, how are you doing all that stuff. So yeah. Okay, Cool. Well, thank you, Yuri, for jumping on the podcast, first episode. Hope everyone watching enjoyed it. If I'll try. I'm not exactly, because this is the first episode, I'm not exactly sure where this will end up. It'll definitely be uploaded to my YouTube channel, but then past that, I'll try and it'll be like available as an RSS feed and everything. So you can probably get it on your favorite podcast app and all of that stuff. And yeah, in a couple of days it should appear on YouTube. But do you have anything else you'd like to say, Yuri?
Well, I would like to say that it's not my first podcast, and I would say it went very well.
That's great.
So I think you did great here.
Thank you. I'm glad you enjoyed yourself. I had fun as well. Hopefully everyone in people in chat is saying спасибо. Так что спасибо. Thank you for coming on, and yeah, hopefully there'll be a lot more Cherno podcasts in the future. As I mentioned in the beginning as well, this podcast was sponsored and is sponsored actually by PVS Studio, which is where Yuri works as well. There's a link over here, so pvs-studio.com/PVS_Cherno for those of you listening who have to type that out. But if it's on YouTube, there'll be a link in the description to some resources as well. PVS Studio, as I mentioned, is a static analyzer. And run it through grab a free trial. #Cherno or #Cherno in the message field will get you a 30-day trial, I believe, for free, and you'll be able to run it through your own code and see what it spits out. It's usually going to be pretty interesting, I think, for people to run it. But yeah, hope you guys enjoyed the podcast. Thank you, Yuri, once again. And I'll see you guys next time. Goodbye.
Yeah. Bye, everyone.
Doesn't quite work for a podcast.